All right, welcome back. We're going to do some examples of taking a derivative. All right, remember the derivative, f prime at any point x was the limit as h went to 0 of f of x plus h minus f of x all over h. All right, that's the derivative. First example, let's calculate the derivative of the function 2x. Okay? Well, by the definition, f prime at x, it's the limit as h goes to 0 of f of x plus h minus f of x all over h. So that's just definition. Now let's plug in what things are. F is the function 2x, so that's 2x plus h minus 2x all over h. Don't forget those parentheses. If you forget the parentheses, then, well, you won't get the right answer. So simplifying here, this 2x will cancel with this 2x, so we just have an h over h. So it's the limit as h goes to 0 of 1, and well, 1 just stays at 1. It doesn't care what h is. So the answer is 1. So that's our first derivative. F prime at x. Oh, crud. I forgot a 2 here. There should have been a 2h there. Should have been a 2 here and a 2 there. Sorry. So the answer is 2. Let's do another example. Let's look at the function f of x equals x squared and calculate its derivative. So f prime at x, by definition, is the limit as h goes to 0 of f of x plus h minus f of x all over h. Definition. Let's plug everything in. Now the function is x squared, so it's x plus h squared minus x squared all over h. Again, don't forget your parentheses. Remember the way the square works is it's x squared plus 2xh plus h squared all over h. We see we've got some canceling going on. So we get the limit as h goes to 0. Let's factor out an h. We'll have h times 2x plus h all over h. So the top is indeed 2xh plus h squared. Let's cancel those h's. So we get the limit as h goes to 0 of 2x plus h. Now this h is zipping off to 0, so and the 2x just stays 2x, so the limit is 2x. So f prime at x is just 2x. And again, alternately, you could write it df dx at x is just 2x. Just different notation. All right. One more example. Let's consider the function, the sine. Okay, and take its derivative. So again, f prime, well, let's write it this way. D by dx of the sine, so we're taking the derivative of the sine, is the limit as h goes to 0 of sine at x plus h minus sine at x all over h. So this is the limit. Well, oh, I see. We do want to do this derivative later on, but right now we can't. We don't have the technology developed for it, so we're just doing the derivative at 0. Okay? So alternately, you could have written this as f prime at 0. All right, so it's the limit as h goes to 0 of sine h minus sine 0 all over h. Now sine 0 is 0, so it's just, so that guy goes to 0, sine h all over h. And we did this limit. Remember, we usually used an x, sine x over x, but sine h over h We did that using the squeeze theorem, and the answer is 1. So the derivative of the sine function at 0 is 1. All right, that's it for derivative examples. Ciao.